Hi, my name is Phillip D. Villanueva.
My name is Nilking I. Palino.
My name is Benjoe G. Gaburno.
Hi, my name is Emmanuel Jovir Ellezo.
My name is Mark Jazer Vacalares.
Okay, so first of all, you need to load the project, and then you need to input what type of simulation or analysis type you are doing. And then for in this case we have the rotation, and then it is time dependent. Okay, and then next we must input what type of liquid we are using, and in this case we are using only water because this is a water turbine. Okay, so you wait until all the parameters are done with the input. You just wait for it to finish loading or recognizing the fluid volume, and here we are. So first step is we must input the fluid subdomains. We must choose what phase, or we must choose the phase that we will be inputting the water, and then the rotating regions. So we must choose the Pelton wheel, and then you must input the parameter rad per second. So in this case we are inputting negative 500. We are only putting negative here because of the direction of the flow, or the flow direction. Then you just wait for it to finish loading. And once it is finished, we must put the boundary conditions. So in here we must put the outlet volume flow, and then input the flow parameters. Notice that note that the input parameters are the flow rate of our turbine. And then next we must put again the input volume inlet volume flow, which is also the value of our flow rate. And then next we must put we must input the surface goals. So in here we must choose the phases, or we must choose all the 16 buckets of our design. So this process takes a while because of how many buckets our design has. And then next you must choose the torque X, and then the global coordinate system. So again it did not detect the 16 buckets, so we must input it again. We must choose all the 16 buckets as our surface goals. So once all of the parameters are done with the input, or once all the parameters are done input, we can now run the simulation and then wait for it to be finished, and then we can print the reports or print the data that we are needing. And so now next I will display the simulation process, or the simulation video of our design. So here you can see the front view of the simulation, which is running at 360 iterations with a minimum velocity of 0 meters per second and a maximum of 38.5 meters per second. So once the iteration reaches 360, the simulation is over. Then the next one is the top view of our simulation. So here it is. This is also running at 360 iterations. So it displays the minimum and maximum velocity of our nozzle or our fluid. So once again, once the iteration reaches 360, the simulation will stop because it has enough data to produce results of the simulation.